Okay, so now, so we have the constraints involve these variables, W, S, V,
Okay.
and U.
Okay.
Okay, so so in fact there should be a matrix for each one of these.
Okay.
There should be a matrix for W, a matrix for S, a matrix for V, and a matrix for U.
Okay.
Now I'm trying to remember. W was the I don't remember. W is
Waiting time.
waiting time.
Waiting time.
Right. That's right. So and how many variables are there for waiting time?
You have to check the Word. I
Uh,
think it's in the Word document.
okay. All right. So let's go back to the Word document. Probably can't. I know the best way to find it is probably here. I guess it's this one here. Let's see. I'm not sure which one it is.
Yeah.
Is
Yes.
it this one here? Yeah.
That's the one. Yeah.
Right.
It's that
Okay.
one.
Yeah. Okay. Oh yes. Okay. So you have A, D, X, Z. Okay. And we have okay. Yes. W. This is the lateness. Is this what two machines?
Okay. Lateness.
W is lateness. Okay. And it says there's n variables.
Mm-hmm.
And then you have U. And this says there's 2n squared binary variables. And then you have S. Starting times. It doesn't say how many variables. Oh no.
Yes, it did.
2n squared. Yes. Okay. Yes. Okay. And then the late indicator. There's n variables. So we have 1, 2, 3, 4. But I think actually, since U has two indices, we should make two separate matrices here. It might be easier. And since there are two indices here, it might be easier to have two separate matrices there.
Okay.
And you see the order here. We have the order here.
Yes, which was still defined
yes.
down.
So if I start this, and let's see what we can do here. Oh, maybe I can actually do this. Okay, we go to. Oh no, it's not this one. Sorry. All right, so
yeah.
Let's go here. So do.
Yes, that this is where you did explanation.
So here's create, constraint, matrices. Okay. All right. So we have
constraints.
So let me copy the. Oh, I guess you can do this here.
Constraints with the T.
Let's see. Is it coming? No, it's not coming.
I said constraints with the T.
Okay, it's not working. Let's try again. Well, it's not working here. Sorry. There we go. Okay. All right. So we have W. We have W, S, V, and U. Oh, let's see if this is going to work. I may have to change computers.
Yeah.
Let's see if this is going to work. Okay.
Can we see create?
Okay, let's see. So we've got, here we have n variables. So, let's see. That looks like it's going to work. So let's go here. Okay. So if I want to label the matrices, this is going to be W. And I think we'll have two different S's. We'll have S1. This can be S2. Actually, it doesn't stop there. Sorry, it's not. S1 goes all the way, because S1 has a 1 at the end. So it goes all the way to here. Oh, here's S1.
Okay.
Here's S2. Here's V. Here's U1. And here's U2. Okay.
So we have 6 matrices.
So you have 6 matrices. This one has n. This one has n columns. This one has, if you look at this, it goes from 1, 1 to n. So this one has n squared columns. This one also has n squared columns. This one has n columns. This one has n squared columns. And then this one has n squared columns. Okay. All right, so let's look at the first constraint, the first equality constraint. First equality, well, we can pull it from this document. It's also in the. All right, so here's the first equality. Here's the first equality constraint.
You said the UN is the.
This one here. Actually, it's the first. Yes. It's the very first one, right here.
Okay.
It's not giving me. Oh, it's too hard. Let's try this. It's not allowing me to select what I want.
You want to select just that first one?
I want to select this first one. Yes.
Yes. Okay. No.
Well, this is the best I can do. I'll go to your Jupyter document. I think that's probably better. What you had here was here.
That's it.
Yeah, but there was a expression. Oh, it's here. Is this one right
here?
That's
what I'm saying. Yes, that one. Yeah, that one.
Okay.
Yes.
All right. So we want to create the. So we need to create. So we want to create W, S1, S2, V, and U1 matrices for these constraints. For this constraint. Oh, sorry. Don't know why it's doing that. Okay. All right, so I need to go down here. Okay, there we have. Okay.
Okay.
All right, now, so I want to create. W, S1, S1, S2, V, U1, and U2 matrices for these constraints. Okay. Now, how many constraints are there in this set? How many constraints are there?
Yeah, for the summation of UN. The first one, you have UN.
It might be clearer from here. Well, it's the same. It's the same constraints here, but it might be clearer from here. Okay. So here it says the sum over n of UNK1 is equal to 1 for all k. So for each different value of k, you have a different constraint. So how many different values of k are there?
We have two. We have the first U and U11 to UNN1.
Okay, yes, that's right. Yeah, that's what we showed up here.
Then the other, yes. Then the other one, yes.
Okay, yes, that's right. Yeah, we had up here, yes. Okay, so how many different, so K is this, so the first index is small n, the second index is small k. So how many different values of,
Yes.
what are the possible values of K?
We have three possible values.
Say again.
I said we could have three possible values.
And what are they?
You have the U1, that's U11,
Okay.
U112, that's three there, yeah.
Well,
To UNN.
all right, but you see there's a dot, dot, dot here.
Yes, it's because there's a continuation there.
Yes, that's right. So I want to know the total number of values for the second index.
No, 6. 1, 7.
What does capital N mean? Do you remember what capital N means?
Is that not the number of jobs?
And capital N is the number of jobs.
Yeah.
Okay.
That's the numbers of jobs we
Yes.
have.
Yes. So we have U1, we have U11, U12. Suppose there are 5 jobs.
Okay.
Then how many values are there here?
If there are 5 jobs there.
Yes. If there are 5 jobs, how many U's are there? If N
You
equals
have
5.
U,
Yes.
N equals 5.
Oh, yes, that's right. So how many U variables are there? How many variables are there here?
We'll have 5 of them.
Okay, so what are
you
they?
have U and
What are they? So okay,
U.
so we'll give an example.
Okay.
5 jobs. So that means N equals 5. Okay. So the number of the variables. If I take these variables U, I guess we're calling them NK. Okay. R the first, well, NK1. All right. So the first one is U111.
Yes, U111.
Okay. 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 So continue.
U 121.
Okay.
U131.
Okay.
U141.
Okay. Yes. Okay.
U151.
Okay. Yes.
So
Is that all?
we have 5 jobs now. We are looking at N.
5 jobs, but not 5 U's.
Okay.
So there's more variables. There's more than that.
So you have U161.
No. No.
No, we still have sorry, your first job. First machine, first one. The other one.
Okay. Okay. Here it says UNK1, right? What values can N take?
You said?
What values can this N take?
It can take only 5 values.
Okay.
According to what we have.
Okay.
So we are still going to look at the second machine now, right?
No, it's not the second machine. No. No, these are all for the first machine.
Still on the first. Okay.
Second machine means you have a 2 here.
Yes, that's K2.
But you still have more of these U variables. It's not the second machine.
So you have U2, U221.
Okay.
U222.
No.
No.
Because
No, it
no,
can't be
because
U222.
the last one was always 1.
Can you please scroll up a bit?
Okay, sure.
Let me see. I think that click audio is blocking it. Okay, yeah. U221. Yeah, then U 231.
Okay.
U241.
Okay.
U251.
Okay. Okay. All right. So so there are more U variables. What are the rest of the U variables?
And we also have U3.
Okay.
Okay, scroll up a bit. Scroll up.
There's nothing to see up there.
Yeah, something is blocking it on my screen. That's why I said scroll.
There's nothing. There's nothing to see.
No, down.
Okay. Okay.
Sorry,
Yeah,
go up. I
I
want to
see.
see the
Okay.
last thing you
Okay. I
typed.
see. Okay. I see.
The
Okay.
last thing you typed.
Yes.
Yes,
Okay. I see. Okay.
exactly.
Okay. Yeah.
Yeah, U321.
Okay.
Then you have U331,
Okay.
U341,
Okay.
U351.
Okay.
Okay,
Okay.
I think it's getting clearer now.
Okay.
Yeah.
All right. Good. So any
Then
other?
we still have U421.
Okay.
U421. Then U431.
Okay.
U531. U551.
Why are you changing
U5.
the
Oh,
pattern?
sorry. Yeah, it's okay. It's okay.
Yeah.
U451. That's okay. Yeah, that's okay.
Okay.
That's okay.
Okay. And then what else?
Then you have U521,
Yes.
U531, U541, U551.
Okay. All right. So how many variables altogether?
Wow. So we have we have 4. Yeah, that's 16.
16 here.
20. Yeah, 16. Yeah, plus 21.
Okay. Now my question is,
20.
why do you have 5 variables here but only 4 variables here?
I think it's because we only have 5 jobs. We can't have, because here we are starting with 2111. I don't think we can have 2121 again. No. We have 5, we have 4. That's true.
What this means is that job 1 is in position 1. This one says job 1 is in position 2, job 1 is in position 3, job 1 is in position 4, job 1 is in position 5. So this one says...
that the second one is job 2 is in position 2.
Yes, okay.
Job 2 is in position 3.
So are these...
Okay.
So are these all... Is this a complete list then?
Do we still have another list?
Well, I still don't understand why there are 5 here and only 4 here. And here, job 1 can be in position 1, or it can be in position 2, or position 3, or position 4, or position 5.
You know, we can't have job 1 in position 2 again because we already have that in the first arrangement. So that's why we have to start from job 2 in position 2.
So why do you have to start with job 2 in position 2?
Because we are done with job 1 from the numbers of jobs given.
That's true. You're done with
We've
job
already
1,
had,
but you're not done with position 1.
yes,
All right.
job 1 in position 1, job 1 in position 2.
Yes.
We can't have another job 1 in position 2.
All
We
right,
already have it in the
so let me
stage.
give you an example. Suppose I have my jobs for machine 1.
Yes.
Suppose I have 3, 2, 4, 5, 1.
Okay.
All right, here you have job 3 in position 1.
Mm-hmm.
So this means that U 3, 1, 1 is equal to 1.
Yes.
Because job 3 is in position 1.
Mm-hmm.
So why don't you have, I don't see U3, 1, 1 here.
U311. Job 3 in position 1. Oh.
Or I could have something like this. I could have 2, 3, 2, 4, 3, 1, 5. Okay.
Mm-hmm.
Now, if the 2 is in the first position, what does that mean? What does that tell you about you?
That's job 2.
No, it's not. Yeah, job 2.
1.
Job 2. Yes, job 2 in position 1 on machine 1.
Mm-hmm.
Okay. But you don't have U2, 1, 1.
That means we skipped that.
So I don't know why you skipped that.
No, we skipped that. It should be, it has to be after U11, you have U211, U212, U2,
No.
U3.
You see that that job 2, here you have job 1 can be in position 1, job 1 can be in position 2, job 1 can be in position 3, job 1 can be in position 4, or job 1 can be in position 5. Now job 2 can also be in any position.
Job 2 can be in position 1.
Yes.
It can be in position 2.
But you don't allow it, but you didn't allow it to be in position 1. You don't allow it because you don't have U211.
Yes, we skipped that then.
Okay, so that's missing.
Yes, it's missing. Yes, we skipped it.
So
it's supposed to be there.
So it should be
So it has to be down.
Okay.
Yes. U211.
Okay. Now what about job 3? What?
So yes, U311.
Okay.
Yeah, that's true. That's true.
Okay.
Then U411.
Okay.
Okay, yes. Yes, it should be the same. U411, then U511.
Okay.
Okay.
All right.
Still enough.
So how many variables do you have?
So we have 5, 20,
Okay.
25.
Okay. All right. So
25 variables.
So the first index equals n. Right? We have 3 indices, right? The third index is always 1.
Yeah. Yes.
Okay.
Yes.
Okay. So the first index takes values. What values can the first index take?
The first index.
Yeah.
You're talking about the position of the first one.
No, see, there are 3 indices here. The first index,
Yes.
second
Top
index,
one.
third index. Right?
Okay.
In this case, the first index is 2, second index is 5, third index is 1. So what values can the first index take?
The first index takes values from 1 to 5.
Yes, okay. And that's the first index is n.
Yes, 1 to 5.
So there are 5 values.
Mm-hmm.
Okay. What about the second index?
The second index, that's the first one is 1 to 5. The second one is also 1 to 5.
So the second index can also take 5 different values.
Yes, 1 to
Okay.
5.
All
Yeah.
right.
And then
So
the third.
it goes back to my question.
Okay.
For each different value of k, there's a different constraint. So how many constraints are there? Since there are 5 values of k, then how many constraints are there?
And that's the 25. It's not the 25 you just did now. 25 constraints there.
No, there's one constraint for each value of k.
The one constraint, are you talking about the last one
I'm talking
value?
about this. I'm talking about this set of constraints here.
Okay.
We're looking at these
okay,
constraints
yes.
here. And I say for each value of k, there's a different constraint.
And it's just one.
How many values of k are there?
It's just one value of k.
No, there are 5 values of k. You just finished telling me there are 5 values of k.
Where is it?
There are 5 values of k.
Okay, yes,
you
5.
said 5 values of k.
5, yeah, sorry.
Okay. So there are 5 values of k. So there are 5 constraints.
And 5 constraints.
So there's actually going to be, in this case, there are going to be n constraints.
Okay.
Okay. All right. So let's look at the case where so here still we'll look at 5 jobs here. So we'll look at these constraints in the case of n equal 5. Okay. So let me copy this constraint again. Here's the sum here. I can write this better. Okay. So in this case, this is sum over. So let me change this. I'll make this an equation. That didn't work. Sorry. It's not working. So I'll just rewrite the equation. So the equation is this way: sum, and then here it says over n, but n goes from 1 to 5, and then this says u nk1 is equal to 1. Okay, and this is for all k.
Yeah.
And this is for k equal to 1, 2, 3, 4, 5. Okay. So the constraint for k equals 1. What is this constraint when k equals 1? Well, when k equals 1, you're taking the sum from n equal 1 to 5 of u nk1. So always the second index is 1. So in the case when k equals 1, you'd have u, first value of n is 1.
Yeah.
Okay. Plus u 2, 1,
1
1.
to 1.
No, because
two,
k
1.
is always 1.
Okay.
U,
Okay. Yes.
3, 1, 1.
U 4, 1, 1. U 5, 1, 1.
Okay. Okay. All right, now what about k equal 2?
So that will be for the second one. U 1, 2, 1.
Okay. Okay.
Then U 1, 2.
Okay, and so on.
U 4, 2, 1.
Okay.
U 5, 2, 1.
Yes, okay. And then, so I'll just say ... and then you get to k equal 5.
Five, 1, then 3, 5, 1.
Okay.
4, 5, 1.
Okay.
5.
Okay. All right, now,
5, 1.
so there are 5 constraints So that means there are 5 rows in the constraint matrix.
Yeah, 5 rows.
Okay. Now all of these variables are U1 variables. Do you see up here we had U1 and U2. So these are all U1 variables.
We still have, okay.
Okay. Now the U1 matrix has n squared columns. So that means the U1 matrix for these constraints has, well, in this case we're using 5 squared columns because n equals 5.
Yeah.
And 5 rows. Okay. All right. So these equations are all expressed in terms of the constraint matrix. The constraint matrix must express these equations. Okay. So what do we have for U1 then? So the U1 matrix, each column corresponds to a different variable.
Okay.
All right. So the columns, the first column is U11. In fact, we showed the columns up here. They're right here. These are the columns.
Okay.
Okay. So if I write them all out in this case, because I put dot dot dot, so if I write them all out, they will look like this. So the full list of columns will be this. I'll start with, oh, this is too big, sorry.
Okay.
I have to make it smaller. Okay. So the first column will be U111. Second one is U121. Third one is U131. U141.
U141.
U151.
And the last one.
And what's the next one? Hello?
Yeah, hello, sir.
Okay, good. So let's continue. So what's the next variable? Remember, there are n squared variables. So here we have only 5. There are 25 variables. What's the next variable?
Sorry, my screen is still coming up.
Okay, sure.
Okay, it's off now.
Right, okay.
All right.
So what's the next variable?
That's from what we've listed before.
Yeah, here's
U1, 2, 1.
I already have U1, 2,
You
1.
have,
I already have U1, 2, 1.
okay. And U2, 1, 1.
Okay, that's good. Yes, that's right. Okay. So next one is U2, 1, 1. And then the next one?
U2, 2, 1.
Okay, good. And then U2, 3, 1.
Yeah.
U2, 4, 1.
U2, 3, 1. U2, 4, 1.
U2, 5, 1. All right, then what's the next variable?
U3, 1, 1.
U3, 1, 1. Okay. And then here we can go up to U3, 5, 1. Okay, etc. Okay. All right, now we have to express these constraints using these variables. The first constraint is this one. U1, 1, 1 plus U2, 1, 1 plus U3, 1, 1 plus U4, 1, 1 plus U5, 1, 1 equals 0.
Okay.
U1, 1, 1. There's a 1. This is 1 times U1, 1, 1, right? This is 1 times U2, 1, 1. This is 1 times U3, 1, 1. 1 times U4, 1, 1. 1 times U5, 1, 1. So that means 1 times U1, 1, 1 plus 1 times U2, 1, 1 plus 1 times U3, 1, 1, and so on.
Okay.
And these are not there, so they're all 0. 0, 0, 0, 0, 0, 0, 0, 0. And so these are all 0. And then here, this is going to be U4, 1, 1. And here's a 1 here. Okay. So that's the first row of my constraint matrix.
Okay.
What about the second row? The second row comes from the second constraint, which is up here.
Which is 2.
Okay. What about this? So, all right. So, what about the second row of the constraint matrix?
So that's giving us K2.
That comes from here.
2 times each of them.
Okay. So
Yes,
where are the ones?
The ones.
I mean, how do I express this constraint using a matrix?
Okay. You have K equals 2 here.
Okay. Where is U1, 2, 1? Which column has U1, 2, 1?
U1, 2, 1. That's U1, 2, 1. That's the second column.
Yes. Okay. Okay. Where else?
Then U2, U2, 1, 1.
No, it's not. No, it's not 2, 1, 1.
U1, 2, 2.
No, it's not U1, 2, 2 either.
Oh, sorry. U1, 1, 3, 1.
No, it's not U1, 3, 1 either. I'm doing this constraint here. I'm doing this constraint here.
We started with
Yeah.
U1, 1. Okay. Then U1, 2, 1.
Right. U1,
2, 1. U1, 3.
No. Just read down the row.
Straight down the row.
Yes. Where's the next variable?
According to what we've listed before.
Yes. The first variable was here. First variable is here, U1, 2, 1. Where's the next variable?
U2, 2, 1.
Yes. Okay. So what column is that?
That's the third, fourth, fifth. The seventh column.
Okay, yes. It's not working for me.
Seventh column.
Right, okay, so let me go there.
2, 3, 4, 5, 6,
That's
7.
that's here.
Seventh column.
Yeah, sorry.
Yes. Then you 3, 2, 1.
It's right here. It's this one here,
Mm.
and then there's one here. And all the others are zeros.
All others are zeros. So the U5151 is going to be down. That's
Okay. So
1, 2, 3, 4. The fifth column.
0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay. All right, so what about the next one?
It will be on the fifth column.
No, that's the last one. You see I put dot, dot, dot.
And that's U151, right?
That's the last one. You see I put a dot, dot, dot here. Because I didn't want
Yeah,
to
we
write
have
them
the
all.
dots
I
there.
didn't want to write them all out. You have to see the pattern. I didn't write the next one because I put dot, dot, dot here. The next one
you
is
didn't write
the next one is K equals 3.
U131.
Yes. Okay, where is
That's the third column.
that's the third column. Yes.
Third.
Yes. Okay. So
That's
it's
the
here.
third column.
Right there.
Then the other one is going to be on the fourth column. The second,
Okay.
yeah. Yes, you didn't write it out.
Okay, and so on.
Yes.
The next one will
Fourth
have
column.
ones here, and then the last one will have ones here. Okay. Okay.
Okay.
Okay. So this is a 5 by 25 matrix.
Wow.
No, this is U1.
So this defines our first matching constraints.
That's right. Now, but as I mentioned, you have to have a U1 matrix, U2 matrix, W matrix. You have to have all of these matrices. You have to have a, let's see what the list was. You have to have a W matrix, an S1 matrix, S2 matrix, V matrix, U1 matrix, U2 matrix. We only have a U1 matrix. Okay, so let's look at the W matrix.
So all these matrices are incorporated in the matching variable, the first one.
Every constraint has a U1 part, a W part, a U1 part, an S1 part, an S2 part, a V part, a U2 part. Every constraint has.
Okay.
Okay. Now remember,
So
the W matrix has, in this case, the W matrix has 5 columns. So we're looking at the case n equal 5. So in this case, W has n columns, so W has 5 columns. And then since there are 5 constraints, there are 5 rows also.
Mm-hmm.
All right, now the constraints are here. The constraints are right here. Okay.
Okay.
All right, so do you see any W's there?
No,
No.
there are no W's there.
So it's all zeros.
That's what I want to say, that not everything is written there. There is no W, so all W's are zeros.
Yes. So that means the W matrix is a 5 by 5 matrix of zeros.
Zeros. Okay.
Okay. So W is 5 by 5 matrix of zeros. Okay. All right, now, so we have also the, so we have U1. Let's see the other matrices we need. We also need,
S.
we need S. Okay, S has, S1 has n squared columns. Okay. How many S's do you see in the constraints? And we still have 5 rows. Remember, we're still looking at these constraints here. We're looking at this set of constraints. How many S's do you see?
No S there.
There are no S. So this is
no
all
S.
zeros also.
Wow.
So that means S1 is a 5 by 5 squared matrix with all zeros.
Okay.
What about S2?
Then the next is still the same.
Yes, also
zeros.
5 by 5 squared matrix
Zero.
with all zeros. Okay, now what about V?
Then are there V's there? I know. No V.
There's no V.
No V.
How many variables in V?
All zeros.
V was n columns. So that's
Just
going to
n
be 5
columns
by 5 matrix of all zeros.
of all zeros.
Okay. Okay. So V equals 5 by 5 matrix. All zeros. And finally, you have U2.
Of course, there's U2.
5 by 5 squared matrix.
Mm-hmm.
All right, so where are they? Also no U2s in this set of constraints. There's no U2s.
Just U1.
There's only U1.
Yes. Okay, because one.
All right,
So 3 zeros.
so U2 equals 5 by 5 square matrix, all zeros. Okay? So that means if I was going to do this in Python, sorry. So in Python, W equals np.zeros. In this case, it's going to be, here it says 5 by 5. So, but since we're using n equals 5, this would be n.
Yes.
S1 equals np.zeros.
np.zeros, yeah.
And this has it's n by n squared.
N by n squared, yeah.
Okay. S2.
Then S2, np.0. np.zeros.
N squared.
Oh, n by n squared.
Okay, and then V?
np.zeros.
Yes. Okay, and then I have U2 also.
N by n.
And then np.zeros. And this is going to be n.
Then you have your U.
All right,
U1.
then we have to do U1. Okay. So that's what we have here, U1. U1 we have to do line by line. Because each line is giving us a different one.
That's true.
Okay. So let's start out with, and in fact, that's what's, so to get U1, I would have to do 4, I've got to just say J, in range. So there's going to be,
I can't see what you're typing.
Okay, yes.
Can you scroll up?
Yeah, sure. For J in range of N. All right. Now, let's see. So the first row has a 1 in first
U1.
6 1. This is 0. 0 1 2 3 4 5 6 7 8 9 10.
10.
Okay. So what it says, so first of all, I'm going to start with, most of them are zeros. So I'm going to start with zeros, and then I'll add some ones. So U1, I'll start with zeros, and then I'll add some ones. Okay. So here I'm going to say, in this case, U1, and this is going to be J. And then what I'm going to start with J is the first index. I go to the end, and my increment is n.
Scroll up a bit, please.
Okay, sure.
Okay, yeah.
And this is going to be equal to 1. All right, so you see I created a W matrix, an S1 matrix, an S2 matrix, a V matrix, a U1 matrix, a U2 matrix. Now I need to put them all together into the entire constraint matrix. Okay. So now I want to put these matrices together.
Is that what you said, putting them as one vector?
Yeah, well, it's not one vector, it's one matrix. But I
Can you
mean,
mention vector?
each one of these, each row is a vector
Okay.
as a single matrix. And I think it's np.concatenate. Let me see if that's correct. Okay, let's see what the syntax here is. Okay, so yes, and we'll be joining on the first axis. So this is going to be, so we're going to say, so this is going to be the first equality matrix. Let me call this is the first equality matrix. So it's A equality 1 is equal to np.concatenate. Now in this case we have to put together, I have to put them in the right order. The first was W, S1, S2, V, U1, U2. So W, S1, S2,
S1,
V, U1, U2.
U1, U2.
Okay, sorry. Yes. Okay, so that's the first equality matrix.
Okay.
So that's what I meant, that you have to create matrix for each variable and then put them together.
Wow. Okay, I think it's clear now. So for the other constraints where we have, I think, let me see the other matching variables.
Yeah.
Let me see if I can make some explanation
Okay.
to that.
Sure. All right, so
Okay, now for
this is the next one here.
Yes, we have for all n.
Yes.
The first one is for all k.
Yes.
We are looking at the kth positions.
Okay. So you tell me what is the first constraint? So how many constraints are there? How many values of n are there?
Are we still making use of n equals 5?
Well,
as an example.
As an example, yes. So we can do an example. N equal 5, sure. So in this case, how many constraints are there?
We have 5 constraints as well.
Yes, 5 constraints.
Mm-hmm.
Okay, now you still have the same variables.
You said?
You have the same variables as before, but it's not going to be the same matrix. It's the same variables, though. So let me write out the variables.
But different matrix.
It's a different matrix, yes. Let's try this. Okay, so the variables are going to be U11, still U111, U121, U131,
U12131.
and then U211. Okay. Okay, so I'll just finish from there. Okay. So what about the first constraint?
Now it's not going to be on like we had the first one where we had U11 to be 1, right?
Well, you tell me, when n equals 1, what does this give you? What does that summation expression give you when n equals 1?
When n equals 1.
Yes. What is this? What is this sum? This
UK
UNK1.
to 5.
So what is that sum?
So that would be U1 1.
Okay.
1.
Okay. Plus.
Then plus U 1.
Okay.
2.
Okay.
1.
Okay.
Plus U1 3 1.
Yes.
And U1 4 1.
Right.
U1 5 1.
Right. Okay, there you go. Okay, so now where do the ones go here?
The 1 starts from
There's one here.
U1 1.
Yes, okay. Where's the next one?
The next one will be when n equals 2.
Okay, where's the next one?
When n equals 3. When n equals 4. And when n equals 5.
Okay.
Where the others are 0. Oh, that's the difference.
Okay.
Oh.
What about the second constraint?
So the second constraint now is where n equals 2. So you have U2 1 1.
Yes.
U2 1 2.
Is that right?
No, sorry, U2 U2 1 1. U 2 2 1.
Yes.
U2 2 1. Yeah. U2 2 U plus U2 3 1. Yeah.
Right. Okay. All right. So where are those ones?
So the ones will start from U2 1 1.
Mm-hmm.
Then the other one will start from U2. Oh, I see. U2 2. Okay. So that's the difference between this and the first one.
Yes, that's right.
But for j in range of n will be written differently.
Well, you can still write it the same, but the equation here will be different.
And what I'm saying is, here we had for j in range of n, you are looking at j 2 dots for n. That's, you are picking it after the is it the 5th or the 10th? I think counted 5 equals 1.
Just a moment.
So what I'm saying is that's going to change. That is going to change from.
Okay. All right, so you actually have these are all the same.
Yes, it's just that for j in range of n that I feel will be quite different.
All right, yes, this command is going to be different.
Yes, that one. Yes, that's what I was saying.
Okay.
So that's the one that will change.
Okay. Yes, that was the one that will change.
That's what I was thinking.
Now, in this case, the first one, it starts at 0. Then the next one it starts at
0 or
5,
1.
0. With Python, the first index is always 0.
Okay, yes, that's true. Python first is 0, 0. Okay.
Right. So in fact, this one is going to start at n times j. And then it's going to go up to n plus 1 times j. And then...
Please, can you explain that?
Well, look at the first constraint here. What's the first index?
1.
No, 0.
Oh, sorry, 0.
Okay, and what's the last index? 0, 1, 2, 3, 4.
Okay.
Now, when you do Python, when you do a range in Python, you don't include the last index. So this would be from 0 up to 5. I'm sorry, it's n times j plus 1. Sorry, not n plus 1 times j. N times j plus 1.
Mm-hmm. Okay.
Or I could just do it this way. Probably easier to do this, just n times j plus n. Like that.
N times j plus n.
Yes, so that means there are n consecutive ones.
Okay.
So this will be the second equality matrix.
Okay.
Okay, well, there's going to be another. There's actually going to be two more equality matrices. So you can think about
we
how
are looking at. Yes, I'll think about it.
Yeah, so you can
we are
think
looking
about
at
what to do
K2.
there. Yes.
The K2. That's the second position. That's the second U.
Yes.
The second U2. That's the other part of the U.
Yes.
Okay. Yes, I'll do that myself and
Okay.
get back
All right.
to
Good.
you.
Okay. So you can put this code into your Jupyter notebook, and then you can do do the next two constraints also. So the other two equality constraints matrices are similar. Okay.
Yes, they are similar.
And that would be A equal 3 and A equal 4.
A equal 4.
And then the total equal will be equal to np dot concatenate. And this will be A equal 1.
So you don't bring all the four matrices
you put
together.
Yes, A equal 3 and A equal 4. But this time you're going to put them on top of each other. So you say axis equals 0. So this is another way of creating the equality matrix. And the advantage of this way is it's much easier to verify.
You know, what we are trying to do is to debug the first
So we need to write the code. We need to rewrite the code so it's easy. We'll write another version. We'll write another version of the code and see if we can get the two to agree.
This method.
Yes.
Okay, using this method.
Yes.
Okay. Okay.
All
right.
So yeah, you can complete the other equality matrices, and then if you can figure it out, you can try also to do some of the inequality constraints, because we're going to use the very same method for the inequality constraints.
As well as the equality constraints.
Yes. You still have these, like for instance, this one here, it's only going to have a W matrix because it only has W part. This one is going to have Wn of V matrix here, and so on. This one's going to have several matrices. This one's going to have W matrix, S2 matrix,
S
and
matrix,
U2 matrix.
UN. Yeah. What about the X and the D?
Those are not variables. Those are constants.
Okay.
You already have those defined up here. I'm sorry. Those are not variables because you have those defined up here. There's your X there.
Okay. Yeah, I can see that.
And there's your D.
Okay. Yes, no problem. Please, I would like to show you what do you think we could have as our aims and objectives for the what do we call it now? The presentation that I want to do. Can I show you something?
Sure.
Okay, let me share my screen. Okay, here.
Okay.
Can you read this and see? I don't know. Because I think I'm trying to, I have to define what I need to achieve or what I intend to do.
Okay. Well, I certainly think that's a good start. You have a deterministic approach.
Is it okay?
Yeah.
Okay.
Well, instead of deterministic approach, you can say linear programming approach.
Oh, linear programming.
Yes.
Okay, I'll correct that. Okay.
And for number 3, you can say compare the performance of deterministic and stochastic approaches.
Compare the performance.
Yeah.
Okay. Oh, okay. The linear programming approach. Okay, let me just write it. I'll correct that later. Okay.
So you're going to make a presentation?
Yes, I'm working towards that, but I need to pay my school fees first. So that's why I'm still they're holding on.
Okay.
Then the paper I sent was actually rejected. So I think I got a mail from them. This is what they said. This is the mail.
Okay.
Can you read it?
Yeah, it says outside the scope.
Yeah. Yeah, it said it's outside. So I think I will still discuss with Prof. Adamu. Probably has other journals I can still send the paper to.
Okay.
Yeah. Thank you so much.
Okay,
for
yeah,
your time.
okay. So this is a review. So I guess they're not if it's not a review, they're
probably they don't accept review.
It looks like they don't accept reviews, yeah.
Yeah. All right, thank you, sir.
Okay, all right, very good. Okay. Yeah, we can meet again next week.
Yeah, sure. I'll work on it and get back to you.
Okay, all right.